Today we're going to continue our discussion on quadratic formula word problems. Before you get started, take a moment to find the cheat sheet that I provided for you that allows you to see the different keywords you will see in a word problem to help you determine the formula you should use to solve that word problem. Again, you should probably have that cheat sheet keyword paper in front of you when approaching these problems, especially because we just started with this topic. Now, let's take a look at problem number 1. Jason jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t equals negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. A, how long did it take for Jason to reach his maximum height? B, what was the highest point that Jason reached? C, Jason hit the water after how many seconds? So you can you can just look at the different question that is asking, but we're always talking about a quadratic formula because we see the standard form and we see a square number and A. Again, right here, we can see that it's an exponent with A because this is in standard form. So starting with question A, how long did it take Jason to reach his maximum height? That key word there, maximum height, let us know we should be talking about the axis of symmetry using the formula x equals negative b divided by 2a. So x equals negative 16 divided by 2 times negative 16 equals negative 16 over negative 32, which equals 1/2. So it takes him about a half a second to reach his maximum height, which makes sense. We're talking about jumping off a cliff. That answer really applies to this situation. So then question B, what was the highest point that Jason reached? So if we're talking about graphing this and we have a parabola, the highest point would be that vertex. So we have 1/2 as our time that it took for him. We need to plug that back into our original quadratic formula. So negative 16, and that's a negative 16 times 0.5 squared plus 16 times 0.5. And again, I'm just plugging in that half a second in place of t, which represented time, plus 480. I'm going to let my calculator do the work from here. And once you do that, you should get about 484 feet. This is talking about the highest point, which is distance, and the height is measured in feet from our word problem. So we know h equals 484 feet. Now, the last question, how long or about how many seconds did it take Jason to hit the water? I know right there, that is the quadratic formula. Or you could do the square roots or root way, or you can factor. But to me, it is just easiest in this particular scenario to actually factor. So we're talking about time. And I know I'm looking for two answers, a positive and a negative one, but a negative one wouldn't make sense in this scenario. So I'm going to make my equation equal 0 as usual. And I'm just going to rewrite it. And then I am going to use the factor way. The first thing I'm going to do is take out my greatest common factor, which we always do. And when we do that, we're left with negative 16 times the difference of t squared minus t minus 30. And this still equals 0. So I'm going to factor my polynomial there. And I'm going to come and I'm looking for two numbers that multiply to get me negative 30, but add up to get me negative 1. And I'm going to use negative 6 and 5. I don't need to do bottoms up because if you look, there is no number in front of that coefficient t squared. So these are just my factors. Simple enough. And let me change color so you can see better. So x minus 6, x plus 5 equals 0. Those are my two factors. But keep in mind, this is the quadratic formula. I'm looking for time, so I can't, that's not my final answer. I have to actually solve each binomial. So x minus 6 equals 0, so x equals 6. That makes sense. X plus 5 equals 0, so x equals negative 5. That does not make sense because we're talking about time. Therefore, it will take 6 seconds for Jason to hit that water in wherever he is with his friends. I just went through a thorough example of how you can go about solving these quadratic word problems. If you need to hear this again, I have it on the website so you can reference back to it, or you can have your cheat sheet in front of you to help you solve the rest of the problems. Ask me or Ms. Hill Norman for questions if you have any.